Hi guys, now let's see the code implementation for AND logic gate using this neural networks. As we saw in the lecture video for designing a AND logical gate using neural networks, there we saw that for two input perceptron, the output will be 1 if it satisfies this given condition. Otherwise it will be 0. Then we saw that let's consider my weights to be 1, W2 be 1. Again, this bias, let this be minus 1.5. Now, if I put this all the values in this equation here, then what we get? So then my output becomes equal to, that is nothing but W1 is 1. So it will be just X1 plus X2 minus 1.5. This should be greater than equal to 0. Now, this condition which we defined here for this perceptron, this is nothing but one kind of activation function. Activation functions are the ones which activate the neurons in your neural network. Okay, so we need to define some activation function which will activate your neuron to work in some condition. So now here, this is one kind of activation function called as step. So this is step activation function. So when any value, say this graph is like this for step activation function, say this is 0. So which any value which is less than 0 will be 0, and as soon as some value becomes greater than 0, the value should be, answer should be 1. So this is how a step activation function looks like, and we are doing exactly same here. So that's why we know that activation function used for designing this AND logic gate is nothing but a step function. Now let's see the code implementation for designing this AND gate. Now first thing is what? I will do this import numpy as np. So this numpy is nothing but the numerical Python library which I am importing, and I'll be using this with the variable which I am defining here, say as np. So this np will stands for the numpy library. Now let's go ahead and let's define our activation function which we are using, which is nothing but step activation function, where this step will take input as z, and here my z will work as the equation which we saw, that was x1 plus x2 minus 1.5. So when this equation is greater than or equal to 0, we get output 1, else we get 0. Now let's write a neural network for AND gate. Okay, let's define a function to write this with two inputs, which is nothing but x1 and x2. Now the next step which we will be doing is we will be calculating this weighted sum. We know the equation, that is nothing but W1 x1 plus W2 x2 plus bias. Now once we fill the values where W1 is 1, W2 is 1 and bias is minus 1, our Z becomes equal to x1 plus x2 minus 1.5. So these are the values which we substituted. Now in this, the function which should return is, what I'll do is I am applying this step activation function on this equation z. So as soon as I call this step z, it will go to this function. Now here my z value is x1 plus x2 minus 1.5. It will go here, whatever inputs I am giving to x1 and x2, and then it will calculate this equation. If that is greater than 0, then we will get output as 1. Now let's test the code. So we'll be printing just the simple statements, and here in AND NN, this is our function which we have written for the neural network for AND logic gate. Here first input, my x1 is 0 and x2 is 0. Okay, then next input I'll be giving is 0 1 and so on, like 1 0 and then 1 1. So let me quickly type it here, and these here I am defining in comment section what output are we expecting. Now let's run this code and see what output do we get. So for simplicity, I'll just run this code in this Google Colab so that we can see the output on the spot there. So I have taken that code here and written here. Now let's run this. You can use a shortcut as shift enter to run the cell, and we can see the output here. For 0 0 it's 0, 0 1 is 0, 1 0 is 0, and for 1 1 is we are getting 1. So this is a very standard way to code for this AND gate using this neural network, where we are manually defining the mathematical equation which we need for calculation. Now let's see one more code where we are using this TensorFlow and Keras libraries for designing this neural network to get the output of a AND gate through it. Now let's see that. First things first, let's start by importing some important libraries which we need for our design. So here NumPy we are importing for the arrays. Keras tools is used to build the neural network. So we are taking it from TensorFlow, and this SGD is nothing but the training algorithm, that is stochastic gradient algorithm, which we will be using. Now next step is we define the data for the AND gate, that is nothing but our inputs and outputs. So here X is nothing but the all possible combinations of my inputs for AND gate, and my Y is nothing but the expected outputs from inputs given. So here we get 1 only when both the inputs are 1, rest of the time it is 0. Now let's build a model. Here I'll be writing model, which is nothing but a sequential. So here sequential means layers are stacked one after another. Then the input, which is I am taking as shape, which is equals to 2. That is we have two inputs here, x1 and x2. Then in dense I am saying 1. That is nothing but one output neuron, which will give us a binary result, whether it is 0 or 1. And then activation function we are using here is sigmoid. This will do nothing but squashes our output between 0 and 1. So if our output is greater than 0.5, then it is treated as 1, else 0. Now we saw one more activation function, which was step function, which we were using in the previous code where we were doing the manual mathematics behind it. So the sigmoid is more advanced activation function. Let's see in detail in the upcoming videos. Next step, let's compile our model here. Now here I am saying optimizer, which is nothing but SGD, that is stochastic gradient descent. So this stochastic gradient descent I am passing with a learning rate of 0.1. Then I am next step which I'll be doing is compiling my model. So here loss function which I am considering is binary cross entropy. So this is used for the binary classification tasks like AND gate, OR gate, XOR gates, and so on. Now here I am passing this matrix accuracy based on which we will decide whether my model is trained correctly and how much accurate results we are getting out of it. So this will help us track how well the model is performing. Now as we have all the parameters, optimizers, model, let's train it now. That I can do with a simple command, that is nothing but model.fit, where I'm passing my inputs and the outputs, epochs and verbose. Now here, one thing to remember, epochs is nothing but it will loop through the data set, whole data set 1000 times to learn the pattern, because I have defined epochs 1000 here. And this fit function which we are using here, so epoch is 1000 and the fit function which we are using here, this trains the model on our AND data set. Here verbose, this is the optional argument, but when I defined verbose is equals to 0, so this will do what? This will just hide the training outputs. Means when we run the model, we get something like epoch 1, epoch 2, like that we'll get for thousands. So we don't want to see those, so we'll hide those. So that's why I'm writing verbose equals to 0 here. Now next step which we do is predict. So let's see what we can do for predictions. Let's continue here. So prediction, here I am just saying model.predict. So here we are testing the model on all the four combinations, that is 0, 0, 0, 1, 1, 0 and 1, 1. Okay, and then at the end I am printing the output here. Since the sigmoid gives values like 0.8 or 0.2, we convert to 0 or 1 using the threshold as 0.5. So here that's why we are defining a threshold of 0.5. So if my value is greater than 0.5, then my output is considered as 1, and if it is less than 0, and I'm just simply printing out my output. One thing to understand here is how this stochastic gradient descent algorithm updates my weights. Say if my output is wrong, that is for say 1 1, this input 1 1, I'm still getting my output as 0.3, which will be considered as 0 because it is less than threshold, that is 0.5. So what SGD will do is it will adjust the weights slightly in the direction which reduces the error over and over again until my output, this output which was earlier coming to be 0, starts coming close to the 1, and then until it becomes very close to 1, this algorithm will work. This is how the stochastic gradient descent work. So for now, just understand this. Later we'll see this in detail. Now let's run this code in a Google Colab to see the outputs. Here I have taken the same code for which we saw the explanation of each and every step. So let's run this. Again, I'll use the shortcut as Shift Enter here to run this cell. And when I run this cell, let's wait for the output here. Now the triangle is here. That means the training is going on for the model for the given inputs and outputs. Now let's see. Here we have our results now. See here for 0, 0 we are getting 0, 0, 1, 0, 1, 0, 0 and 1, 1 we are getting as 1. So our model which we trained is working fine and we are getting all the expected outputs for the given inputs. So this is how you can write a code for AND gate. So all the best to you guys. Keep practicing and keep learning. And if you like this video, please subscribe and keep sharing. Thank you.